Okay, today we're going to look at something called the CAST rule, and then we're going to solve a couple of problems involving trigonometry and the CAST rule. But before we get into the CAST rule, we're going to talk about reference triangles, which are going to be extremely important, okay, when we get into solving trig expressions. So, the reference angle, you'll notice they call it theta bar. It's got this little line over top of it. It's the acute angle between 0 and 90 degrees that the terminal side or the terminal arm, okay, I'll draw the terminal arm, or you can see in the picture down there, the terminal arm is the blue line right here in each of these diagrams. So this is your terminal arm. That it makes with the x-axis. This is extremely important too. Always with the x-axis, never with the y-axis. So when you draw a terminal arm that finishes in quadrant 1, what we want to do is make something called the reference triangle. So notice what I'll do is I'll drop a perpendicular line to the x-axis, not the y-axis, the x-axis. And with the blue and the red and the black line, I've created our reference triangle. That's what it would look like in quadrant 1. The acute angle between 0 and 90 between the terminal arm, the blue line, and the x-axis, the black line, is called my reference angle. So in each of these pictures, you can see where I drew the reference angle. In quadrant 2, there's the terminal arm. Drop your perpendicular to the x-axis. So here's the x-axis. There is my reference angle, theta bar, between the terminal arm and the x-axis. Once again, terminal arm finishes in quadrant 3. Draw your perpendicular up to the x-axis. X-axis is here. Your reference angle goes between the x-axis and the terminal arm. So always between the black line and the blue line will be your reference angle in these pictures. Okay, so finishes in quadrant 4. Draw your perpendicular line to the x-axis. Reference angle goes between the terminal arm and the x-axis. Now, you might say, what is the significance of your reference angle? Well, with the reference angle, we are going to be able to figure out our trig ratios. And you'll notice down here, we've relabeled our trig ratios. Typically, sine theta was equal to the opposite over the hypotenuse. Cosine theta was the adjacent over the hypotenuse. And tangent theta will be the opposite over adjacent. This is still true. This holds true. But I want to show you where this comes from, this y over r, this x over r, and so on. Keep in mind, cosecant was the reciprocal of sine. Secant was the reciprocal of cosine, so a over h would become h over a. Tangent and cotangent are reciprocals, so it would look like this, the adjacent over the opposite. So where does this come from? And again, remember we call these the 3 primary trig ratios, these the 3 reciprocal ratios. Okay, so let's look at our picture. We've got an angle in quadrant 1. There's my terminal arm. We draw a perpendicular line to the x-axis. So here's the x-axis. And what we've created here is our reference triangle. So the reference triangle in this picture is right below. It's a triangle formed by drawing a perpendicular line from a point on the terminal arm to the x-axis. Terminal arm, terminal side, terminal ray. Okay, you can call it what you like. But notice this point on the terminal arm, we'll label it x comma y. So what that tells us is that this horizontal distance is the x value. This vertical distance would be the y value. Think about how to get to that point. You would have to go right and up. If you go right, your x values are positive. If you go up, your y values are positive. That's why x and y are both positives in quadrant 1. Okay? Your r value. Now you could call this z, you could call it r. We're going to call it r because we're going to connect all of this to our unit circle, and r will stand for the radius. All right? Like this point would be on the outside of a circle. And you can see the distance from the center to the outside would give you the radius. So that's where the r comes from. Keep one thing in mind, and I'd like you to jot this down. Your r value is always positive, always. Okay? Now, where would my reference angle go in that picture? It's an acute angle formed between the terminal arm and the x-axis. Terminal arm is the blue line, x-axis is the black line. Your reference angle, which we'll call theta bar, would go right here. Now, there's something to be said about this. We can label this diagram. If this is theta and this is my right angle, we would call this side right here the hypotenuse. Directly across from the 90 degrees, or the longest side, would be the hypotenuse. Across from your angle is your opposite, and next to the angle or beside the angle is your adjacent. Now you can probably see where these trig ratios get converted from opposite over hypotenuse to y over r. Okay? The sine of theta, or the sine of theta bar, would be the opposite side y over the hypotenuse r. The cosine of theta would be the adjacent side x over the hypotenuse r. So that's where x over r comes from. Tangent theta is your y value over your x value, or your opposite over your adjacent. Same thing. Opposite is y, adjacent is x. Now, we want to find out what will happen if we rotate these angles into the other quadrants. So what are the other quadrants? Quadrant 2, quadrant 3, and quadrant 4. Well, let's check this out. And this is where we're going to develop something called the CAST rule. So the trig ratios in all 4 quadrants. We're going to answer this question in a moment. Okay, what primary trig ratios are positive in quadrant 1, quadrant 2, quadrant 3, quadrant 4? Well, for starters, let's draw an angle in quadrant 1. There's my terminal arm. We're going to make our reference triangle with the x-axis. There's my perpendicular. All right, let's draw a point on this terminal arm. And then we'll label the sides of the triangle. So this picture is going to look exactly like the previous slide. X, Y, and R. Positive X because I went to the right. Positive Y because I went up to get to that point. My R value, or the hypotenuse, or the radius in this case, is always positive. So in quadrant 1, if I were looking for the sine theta, this is going to be exactly what it showed on the last slide. My reference angle can go in here. Sine of theta is going to be the opposite over the hypotenuse, y over r. Cosine theta is x over r, adjacent over hypotenuse. And tangent theta is opposite over adjacent, y over x. Now, when we go to answer the question, which trig ratio is positive in quadrant 1? Well, which primary trig ratio, is positive in quadrant 1? Well, check this out. The sine of theta, it's a positive divided by a positive. That's positive. The cosine of theta, it's a positive x divided by a positive r. That's positive as well. So is the tangent of theta. So in quadrant 1, all trig ratios, all primary trig ratios are positive. That would also mean that all of the reciprocal ratios are positive as well. The cosecant would be a positive r over a positive y. The secant would be a positive r over a positive x. And the tangent would be the cotangent would be a positive x over a positive y. When you divide a positive by a positive, you get a positive answer. So all of the trig ratios, all of the primary ones, and all of the reciprocal ratios are positive in quadrant 1. Let's move on to quadrant 2. There's my terminal arm. I'm going to draw a perpendicular line. Remember, to draw your reference triangle, always make it with the x-axis. So what I mean by that is sometimes students do this. I made the perpendicular line go to the y-axis. No good. All right? We're always making our perpendicular line with the x-axis. My reference angle would go between the blue terminal arm and the black x-axis. So this is where theta bar would go. Now let's label the sides of our triangle. Now think about how you would get to this point on the blue arm. You would have to go to the left and up. Well, if you go left, your x value is a negative. If you go up, your y value is a positive. And your r is always positive. So when I go to write the sine of theta, let's focus on this picture right here. It's going to be the opposite side. Pause this for a second. I'll plug my tablet in. So the sine of theta would be the opposite over the hypotenuse. So it's a positive y over a positive r. Cosine is the adjacent side over the hypotenuse. So it's a negative x over a positive r. The tangent would be a positive y, the opposite, over a negative x, the adjacent. So it's y over negative x, and I'm just going to draw the negative right here. Okay? So to answer the question, which trig ratio or which primary trig ratio is positive in quadrant 2? Well, you can see the only one of these that is positive here is this guy up here, sine theta. So in quadrant 2, sine theta is positive. Keep this in mind as well. If sine theta is positive, cosecant would also be positive. Right? Its reciprocal would be positive. Cosine and tangent are negative, as are secant and cotangent. Moving on to quadrant 3. There's my terminal arm. There is my perpendicular line. All right, I'm going to kind of slide this negative x this way. How would you get to this point right here? Well, you'd have to go left and then down. So not only would the x be a negative, but so would the y. Remember, the r is always positive, and remember your reference angle goes between the terminal arm and the x-axis. So let's do our trig ratios in quadrant 3. All right, the sine of theta would be opposite over hypotenuse, negative y over positive r. The cosine would be a negative x, the adjacent, over the hypotenuse, r, a positive. And the tangent would be a opposite over adjacent. Okay, this is angle, this is the opposite side, this is the adjacent side, this is hypotenuse. Tangent is opposite over adjacent, or y over x. Why didn't I put a negative and a negative? Well, because a negative divided by a negative gives you a positive. So in quadrant 3, the only trig ratio that's positive is tangent. And remember, if tangent, the primary trig ratio tangent, is positive, then cotangent would also be positive. Finally, move on to quadrant 4. In quadrant 4, we have our terminal arm, our perpendicular to the x-axis. We have a positive x and a negative y, because I'm going right and down to get to this point on the terminal arm. We have a positive r always, and my reference angle would go here. Sine theta is going to equal opposite over hypotenuse, negative y over positive r. Cosine theta is adjacent over hypotenuse, positive x over positive r. And tangent theta is a negative y, the opposite, over a positive x adjacent. So to answer the question, what primary trig ratio is positive in quadrant 4? It's the cosine. All right, and if cosine is positive, keep in mind that secant would be positive as well. The reciprocal ratio secant would be positive. Now, where does this cast rule, or when I said at the beginning, we're going to talk about the cast rule. Notice what I underlined, C-A-S-T. So that's a way you can remember how this goes. And some people like to write the following, for cast. All right, 4 because it starts in quadrant 4. The C starts in quadrant 4, and then you work your way around. A in 1, S in 2, T in 3. And that means cosine is positive in quadrant 4. All trig ratios, A stands for all, sine in quadrant 2, and T for tangent in quadrant 3. So here's some problems where you could work this out, or where the cast rule comes in handy. Okay, so I'm just going to draw C-A-S-T. This is asking there where cosecant theta is less than 0, is negative. Now remember, if cosecant's negative, it's reciprocal, the primary trig ratio, sine theta would be less than 0. So where would sine theta be negative? That's what it's asking. Where is sine theta negative? Well, I know it's positive where the A is and where the S is. That's where it's positive. So that means it would be negative in quadrant 3 and in quadrant 4. Sine would be negative in quadrant 3 or quadrant 4. So when it says where is theta if cosecant theta is less than 0 or negative, you would say in quadrant 3 or in quadrant 4. Q3 and Q4, both places. All right. Sine theta is less than 0 and tangent theta is less than 0. They are already primary trig ratios, good news. First one, where is sine theta negative? Where is it less than 0? Well, I know it's positive in quadrant 2 where the sine or the S is, and in quadrant 1. So it would be negative. Let's do this one in red. It would be negative here and here. Let's do this one in blue. Where is tangent theta negative? Tangent theta is positive in quadrant 3 where the T is, and positive in quadrant 1 where the A is. So it would be negative in quadrant 2 and in quadrant 4. So which quadrant did I check twice? Remember, theta has to be, sine theta has to be negative and tangent theta has to be negative. In order to satisfy both of those constraints, I would have to be in quadrant 4. And finally here, cosecant theta is greater than 0. That means cosecant theta is positive. So it's reciprocal. Sine theta would be positive, and cotangent theta would be negative. So if cotangent is negative, that means tangent is negative. So sine theta is positive, tan theta is negative. Check with the cast rule, forecast, C-A-S-T. Sine theta is positive. Okay, again, I'll go red for this one. Sine is positive in 1 and 2. Tangent theta is negative. Okay, it would be positive in quadrant 3 and in quadrant 1, so it's negative in quadrant 2 and in quadrant 4. If it's positive in these two, it's negative in these two. And which one did I check twice? What satisfies both constraints? Quadrant 2. All right, it's still quadrant 2. It's not the S quadrant. The quadrant 2 is what we're talking about. The S means that sine and cosecant would be positive there. All right, here's a question that I get you to try for homework, so you can pause the video, give that a try. You can also try this one, okay? Pause the video, give that a try, and then I'm going to work them out so you can see the answers when you're done. Start the video up and scroll through and see how you made out. Okay, for starters, this question tells us that secant theta is equal to negative root 10. Okay, so given secant theta equals negative square root 10 over 1. They're actually telling me two sides of the triangle. Which two sides are they telling me? Well, remember, secant is the hypotenuse over the adjacent. All right, but we're not talking hypotenuse and adjacent anymore. We're relating these to our Cartesian plane, our x-axis. So remember, the hypotenuse we're now calling r, and the adjacent side we're now calling x. Secant theta is r over x. So if I go back and show you right here, you will see where secant theta, it's telling you the r value and the x value. Okay, so here's the move. We know that r equals root 10, and we want to put a negative, and x equals 1. What's the problem with that? What did we say about the r value? All right, we said the r value is always positive. So if the r value has to be positive, I got to flip this negative sign. All right, r is going to equal positive root 10, x is going to equal negative 1. Now, they really just want me to find the value of cosecant theta, and remember, cosecant theta is the hypotenuse over the opposite side, or in terms of x, y, and r, it's the r value over the y value. Well, I know the cosecant is going to be root 10 over whatever y is. If you're wondering how to find what y is, you could use Pythagorean theorem. Now, there's a problem with this. When I use Pythagorean theorem here, keep in mind that x or y could be positive or negative when I take the square root. So there's this second condition in here that is telling me what quadrant my angle would be in. So I need to find y, obviously, in order to figure out the cosecant. But in order to figure out what y is, I need to figure out what quadrant I'm in. Okay, so let's try and determine what quadrant is theta in. Okay, well, we know that secant theta is less than 0. That's this piece of information right here. Secant theta is equal to negative root 10. That means it's a negative. Okay, that's what I'm writing here. And we know that sine theta is greater than 0. It tells us that right here. That's that second condition. I can figure this out by doing exactly what I did on the last page. Here's my cast rule. Okay, secant theta is the reciprocal of cosine theta. So that's like saying cosine theta is negative, sine theta is positive. Let's do this one first. It's easy. Sine theta is positive here and here. Now, cosine is negative. I know cosine is positive in 4 and 1. So if it's positive in 4 and 1, it's negative in 2 and 3. Which quadrant did I circle twice? I checked twice. I checked the second quadrant twice. So that tells me where my terminal arm should finish. So when I draw a diagram, to represent my angle, I know that my terminal arm is going to finish in quadrant 2. My reference triangle is going to be made with the x-axis. My reference angle is going to go between my terminal arm and my x-axis, right there. I know that my x value is equal to -1. I know my y value is, wait a minute, I don't know that. And I know my r value is √10. Well, how would you find y? To find y, I'm just going to use Pythagorean theorem. X squared plus y squared equals r squared. Or -1 squared, that's my x value. Y is what I'm looking for. R is this √10 right here. So √10 squared. So I'm going to have 1 plus y squared equals √10 times √10 is 10. Okay? -1 times -1 gave me 1. Y squared is going to equal 10 minus 1. I'll subtract 1 from both sides, gives me 9. Y is going to equal, if I take the square root of both sides, plus or minus 3. Now, which one should I pick? Let's look at our diagram. All right. Keep in mind, to get to this point out here, you'd have to go left. That's why x is negative. But you'd also go up because you're in quadrant 2. Your y value, you have to go up. If you're going up, that means your y value would be a +3. So you don't always pick the positive. You would pick a -3 if my picture was in quadrant 3 or 4. So I'll just write a little note here why I picked the +3. Because we were in quadrant 2. Now, step 4. Find cosecant theta. And we know that cosecant theta is equal to r over y. And in this case, my r value is √10 over 3. Keep in mind, I'm talking r over y. I'm relating my hypotenuse and my opposite sides to the Cartesian plane, the x-axis and the y-axis. Okay? Just note that theta would be the measure of the angle from here to here. Okay? Your reference angle helps you determine that. So the cosecant of theta would be √10 over 3. This is your final answer. Hopefully you got that. Let's look at one more problem involving the trig ratios. Okay. I don't really need the cast rule for this problem, but this is another common type of trig problem you may come across in this unit. All right, it says determine the 6 trig ratios. What do we mean by the 6 trig ratios? Sine, cos, tan, cosecant, secant, and cotangent. Primary trig ratios, reciprocal trig ratios, 6 in total, whose terminal arm passes through the point -2√3, -4. So think about what they told you right here, this information. They gave you x is -2√3 and y is -4. Now, in order to find these trig ratios, I need not just x and y, but I also need r. Right now, I could tell you what tangent is, y over x, and what cotangent is, x over y. And if you're wondering where I'm getting that information from, why I'm saying y over x and x over y, It's because I'm looking at this information here, tangents y over x, cotangents x over y. Okay, so it's helpful to know that information as well, not just the opposite over hypotenuse, adjacent over hypotenuse, and so on. But what I'm missing is r. So step one will be to find r. I don't have to draw the picture. I can find r. We know that r is always positive, and I can find r by using Pythagorean theorem. Negative 2 root 3 squared plus negative 4 squared is equal to r squared. When you square this, negative 2 root 3 times negative 2 root 3. Negative 2 times negative 2 is 4. Root 3 times root 3 is root 9, which is 3. So I'd end up with 4 times 3. Or you could write 4 root 9, then simplify that to 4 times 3, which will simplify to a 12 in the next line. Negative 4 times negative 4 gives you a positive 16. Don't forget, when you multiply a negative by a negative, you get a positive. Okay, some people just jump right in with their calculator. They don't put their brackets in, and they end up getting negative 12 here. Okay, be smart about this. You don't need a calculator to do that stuff. Plus 16 equals r squared. Now, 12 and 16 give me 28 equals r squared. A lot of people take the square root of 28 and they write it as a decimal, so 5 point something. No good. Remember, in the beginning of this chapter, we said we want to leave our radicals, our answers as radicals in simplest form. So I am going to simplify this. So back to the first video of this unit. Prime factorization of 28, 2 times 2 times 7. I have a pair of 2's. I pull them out. I get my r value equal to 2 root 7. Now, again, you could have maybe thought of this as plus or minus. But remember, we always choose the positive r value because we said r is always positive. Keep that in mind. So with the x's and y's, you have a choice between the positive or negative. With the r value, it's always positive. Okay, so now I know that r is 2 root 7. Now I can find all of my trig ratios. So find trig ratios. And we'll want to write our answers as radicals and simple. It doesn't say to here, but I'll do that, okay? I'll show you what it would look like in simplest form. But since it doesn't say, I'll show you where you can stop, and then I'll show you how to put it in simplest form. So 1, sine theta. It's the y value over the r value, negative 4 over 2 root 7. Okay, simplifying this, I'm going to get negative 4 divided by 2. That gives me negative 2 over root 7, and then I will rationalize. So I'm going to multiply the top and the bottom by root 7, which would give me negative 2 root 7 over 7. Cosine theta, it's x over r, negative 2 root 3 over positive 2 root 7. Negative 2 divided by positive 2 is a negative 1, so I'd have a negative root 3 over a positive root 7. And again, I'll rationalize. I want to get rid of the radical from the bottom. So I'm going to multiply both numerator and denominator by root 7. This gives me negative root 21. So use your radical 3 times radical 7, multiply the radicands. 3 and 7 give you 21. Here, you can think of that as root 49 if you like. 7 sevens are 49. But remember, the square root of 49 is 7. Tangent theta is y over x. Okay, it's negative 4 over negative 2 root 3. It gives you a negative divided by a negative. Okay, negative 4 divided by negative 2, that's positive 2 up top over root 3 on the bottom. And in order to rationalize this, I'll multiply both top and bottom by root 3. This gives me 2 root 3 over root 9, which is 3. Now, you might be able to tell what quadrant theta would be in, or what quadrant this was in by looking at this. Negative, negative, tangent's positive, should be in quadrant 3. Well, we can figure that out. I could have drew a picture of this right from the get-go. Right? I know my terminal arm is in quadrant 3. So my terminal arm would go here in quadrant 3. There's my reference triangle. There's my reference angle. I know that x is negative 2 root 3. And I know that y is negative 4. And I know that r is 2 root 7. Not necessary to draw the diagram for this one, but might be helpful. Now we can go with cosecant theta. It's the hypotenuse, the r value over the opposite, or r over y. So it's 2 root 7 over negative 4, which 2 divided by negative 4, that's like negative 1/2. So I'll call it root 7 over 2. 2/4, 1/2. It doesn't matter where you put the negative. Typically, you don't see the negative left in the denominator. Don't have to rationalize anything here. There's no radical in the denominator. Secant theta is r over x. So it's 2 root 7 over negative 2 root 3. This would give me a negative root 7 over root 3. Okay, the 2's will cancel. And then I'm going to rationalize by multiplying both the top and the bottom by root 3. It equals, okay, negative root 21 over 3. And finally, cotangent theta is x over y. My x value is negative 2 root 3. My y value is negative 4. So negative 2 root 3 over negative 4. That gives me positive 1/2. So positive 1 root 3, or just root 3 over 2. Negative 2 over 4 would reduce to 1 over 2. So you can put a 1 in there. Typically don't see it. And that's that. Okay?